All right, guys, we are still talking about the isobaric process. Isobaric process. Right? So in that video, we were deriving the formula for work done, the equation for work done, how it is formed. Now here we are deriving what we call it, denoted by letter Q. So it in isobaric process where pressure is held constant. So now how the equation of it is being derived, despite you understanding that uh, it the specific heat capacity which is induced to the system to raise the initial temperature to the final temperature. So now guys, for you to understand this isobaric process under it, the heat formula, or rather the heat equation in isobaric process, you need to understand the steam table. So you need to know what the steam table is, or rather how to interpret the symbols of the steam table. That's when you understand how the formula for it is being derived. So for the it, the word it, we all know that this it in isobaric kind, you need to know this before we derive the equation. There are some properties of thermodynamics we need to know, and this property is one of enthalpy. Enthalpy, when you talk of enthalpy, you are simply talking about the amount of heat in a physical substance, or rather in a physical system. The amount of heat, that's the only keyword here. It is the amount of heat. The amount of heat. This is enthalpy. So when you happen to hear the word in thermodynamic enthalpy, they are talking about the amount of heat. So let me give an example of water. Water, before it is applied to that water, it is having the enthalpy, which is the amount of heat that water required in order to boil at the 100-degree temperature. So this is the enthalpy. So now, enthalpy being the amount of heat. So now, being the amount of heat needed. So now we say that enthalpy its what? Its volume. So enthalpy has its own formula. So how do we calculate for enthalpy? Enthalpy, we say enthalpy is denoted